Hello, I'm Lee. In this video, we're going to look at the array implementation of a stack. So let's first take a look at the stack ADT. It has a constructor and destructors, and the two major operations for stack is push and pop. So for push, you just need to add on top of the stack a data item, and for pop, you need to remove that data item. So from this prototype, we see for push, you need to pass me the data item to be added. I'm going to push it on top, not anywhere, just on top of the stack. And for pop, this prototype shows you're going to remove the top item and return the top item through this parameter list. Both functions return a boolean. So a boolean in push could mean like the stack is already full, either because it's a static array or the business logic says at most you could only have certain number of items on the stack. And pop also has return a boolean. It could be when you're trying to pop an empty stack, then it should give you back false. And peek will just return the top item without removing it. So just take a peek. So that's why it's a constant member function and is empty to tell you if the stack is empty or not. The display function here is just for debugging purpose, and the write out is just to save out to the file. Alright, so our first implementation is to use an array to model a stack, and we choose to use a dynamic array. So now let's take a look at a picture here. So we're using a dynamic array to model stack. So for dynamic array, we still need to allocate this memory. It's just when we allocate this memory, it's going to happen at the runtime, not at the compile time. So when we talk about stack, it's a position-based ADT. There's one position we're interested. That's a top of the stack. You push on top, you pop from top. So we have to think about which end of the array should be the top. Is this 0, index 0? Is this, how about assume we have 3 items on the stack. Is this 0 or this size -1? So think about which end should be the top. So now let's think. If this end is the top, assume we say top is this end, the 0 end. And if we want to push on top, that means everybody has to shift down to make space for this top item. And so that's not a very attractive solution. If we want to pop, we have to say, oh, everybody shift up to remove that item. So, bad idea. Okay, now let's think about this one as a top. If you use the end of the stack, this one as a top, if we want to push something, push here, that's easy. You just put the item here, don't bother anyone, and increment your top. That's it. And to pop, even easier. You just decrement your top. That's all. Alright, so that's what we did with the implementation. Let's take a quick look at the implementation here. So let's see. For the push, we first test if we reach the capacity or not. If we already reach the capacity, we're going to expand the array. Then we increment the top and set the new data at the top. For pop, let's take a look. So test if it's empty or not. If it's empty, we don't do anything. Otherwise, we just return the top data through the parameter a data and decrement the top. That's it. Simple enough. Thank you.